Hi, everyone.
Hi, Emma. Morning.
Good morning. Sorry about that.
All good. Um,
Awesome.
I guess I can just sort of give an intro from HackIllinois then. Hi,
Perfect.
my name is Raga. I'm one of the staff members of HackIllinois. We're so excited to present to you guys Intro to API, sponsored by Wayfair. Shai, Emma, I'll let you guys take it from here.
Awesome. Sounds good. Welcome, everyone. Thanks so much for attending our event. If you could go to the next slide, Raga, that would be great.
I think that's actually mine.
Oh, it's on your end? Awesome. Perfect. So I'll just run through a quick agenda of our workshop here. So we'll do some quick introductions from myself and Shai, and then Shai will get into the workshop presentation, and then we'll leave some room at the end for Q&A. And if you want to, you can just record your chat in the chat, your questions for the Q&A, and then we can go through them after the presentation.
Cool.
Awesome. Next slide.
There we go.
Thank you. Awesome. So my name is Emma. I am a campus recruiter here at Wayfair. My alma mater is Franklin and Marshall College, class of 2019. It's in Lancaster, Pennsylvania. If anyone knows where that is, good for you. Very small town in Pennsylvania. And some of my favorite hobbies are traveling, tennis, and all things Disney. Further into this presentation, we'll have some links to our career sites, and I will be online as well throughout the weekend with some other Wayfair representatives asking about if you have any questions about careers or Wayfair, what we're doing, feel free to connect with us on the Wayfair thread in the Discord channel, but that is my email and my LinkedIn as well. Awesome. Shai, you can go ahead.
Yeah, hi, my name is Shai Sachs. I'm a UIUC alum. I got my master's in 2003, computer science department. These days, I'm a staff engineer at Wayfair. I've been here actually just over 3 years. And I work on the API Gateway team inside of our cloud native organization. I've been kind of like obsessed with APIs for a good long while now. Seem to find my way to whatever kind of API thing is going on in a given place. So that's kind of fun. On weekends and, my free time, love to read something about cyclist, etc. and so forth. Take down my email and my LinkedIn address if you want to contact me afterward. So it's really good to be back. Even though I'm not actually on campus at this moment. It's always fun to chat with other UIUC folks. All right, so today I'm going to talk to you about APIs, what they are, how they work, and I'm going to also talk about kind of a somewhat more advanced topic, API gateways toward the end. That's actually what I'm working on at Wayfair these days. It's kind of interesting, sort of gives you a feel for how APIs kind of come to life. All right, so what is an API? The acronym stands for Application Programming Interface, and here's what that means. If you're familiar with Venmo, typically you use it, if you go out for drinks with a friend and you split the tab and you want to pay them back the next day, you go to Venmo, you type in, $10, you type in the name of your friend, maybe you leave a note, click pay, and you're done, right? API can do the exact same thing, except that it's not a person pulling the trigger, it's an API, right? And so the way an API works is you have one computer, which is called a client, that sends a specially formatted message, which looks something like what you see here on the right, sends that specially formatted message to another computer called server. Server sends back a response, and in the process, payment is made, text message is sent, Wordle is played, what have you. So what's so great about APIs? There's a lot of things, but I've tried to kind of distill it down here. As a developer, it's pretty easy to get it started, to get an API kind of off the ground. It's pretty easy to document them, pretty easy to test them. And we'll go into kind of how you do that in a few minutes. What I think is really exciting about APIs is that they kind of create these building blocks and you can use them in all sorts of interesting ways. So if you think about payments, let's take a sort of more interesting case, right, where maybe I want to pay my friend every 2 weeks, right? There's, maybe we have some kind of ongoing arrangement with drinks, right? And every 2 weeks I would need to pay him $10. I could do that myself. I could go online every 2 weeks and kind of try and remember and keep up to date with that. But you can make a computer do things every 2 weeks very easily, right? You don't have to remember, you just set it up, you're good to go. Similarly, like conditional things, right? If you can imagine a slightly different scenario, like, yeah, I'll pay you, but only once, something arrives at my door, right? You can write an API to actually embed that kind of conditional logic and say, okay, when the following, 2-3 things happen, then we'll pay you. So this function that once was something that a human would have to do kind of manually, all of a sudden becomes like a little building block, and you can sort of reuse it in lots of interesting ways. And we're really seeing that take off in the last few years, especially with like Twilio and Stripe and similar kinds of providers that are doing all sorts of interesting things with APIs. The world of APIs is pretty large and complex. There's lots of different kinds of APIs, and even the very kind of simplified overview on this slide is a distillation of lots of other stuff that's going on. But basically, what you typically encounter is two kinds of APIs. On the left-hand side, you have HTTP APIs. These are APIs that happen over HTTP. As I said, a client sends a message using the HTTP protocol to server sends a response using the same protocol. And there's a few different flavors of that, as I've indicated here. There's SOAP, which is a fairly old protocol from like the early 2000s. There's REST, which got its inspiration from a paper in I think the mid 90s, but really took off somewhere in the like 2005 type timeline. And then there's Graph. My history is not quite good here, but I believe it's about 10 years old, came out of Facebook. On the flip side, you have APIs that are outbound. So instead of the server waiting for some kind of request, the server will actively post out data in some form or another. If you kind of want to extend this payment situation, the server will actively post out a message like, hey, somebody just made a payment. Anyone who wants to find out about that, here you go. And that can be interesting for all sorts of reasons. Maybe you have another service somewhere that will send an email every time someone made a payment, or will post to Facebook or what have you. In this talk, we're mostly going to focus on REST APIs, but we'll get into some of the other things as well, just very lightly. So here's what a REST API looks like. I kind of painted a quick picture of this earlier. You have an HTTP request message on the left-hand side, and you have a response on the right-hand side. The client, composes a message like this, sends it to the server. The server sends back a response. Both the request and the response will have headers that contain metadata that sort of describe the message. So on the left-hand side, who is sending the message? This is obviously a pretty contrived example from Harry Potter world. You have Hermione Granger sending this request, the format of the request. On the left-hand side, you have the status of what happened, like, oh, an object was created on the server and so forth. Then you have the verb and the route. In the RESTful idiom, the verb and the route indicates a resource on the server, and the verb indicates what the client wants to do to that resource. So this is shorthand here. We see here shorthand for, please create a payment resource on the server. The body describes the actual resource to be created. So I want to create a payment resource, amount of $100 to Harry Potter, et cetera, and so forth. Server responds back with additional data about the payment object. Okay, it's got such and such an ID. It was made at such and such a date, Halloween on 1997, et cetera. Not every request and not every response looks exactly or even a little bit like this, but this is the general flavor of how it goes. The whole thing, part and parcel, is called the contract, and this is from the legal domain. So, if you go and sign a contract with your employer or with your neighbor or your landlord or what have you. It basically says, okay, I'm going to pay you such and such amount of rent every month. You're going to let me live in such and such a place, and you'll maybe shovel the sidewalk and this and that, the other thing, right? So it's a, one side, does something, the other side does something else, and that's the contract. It's the exact same idea here, with quite a lot less lawyers involved. But basically, the server makes a contract with the client and says, if you do this, I'll do that, right? There can be errors in APIs as well. So in this case, we're sending -$20 to this unknown person, Superman, and the server is responding and saying like, hey, this is nonsense. Like, please clean up your act. This payment makes no sense to me. You got some error messages. This again is part of the contract, right? So a contract has a lot of different pieces to it. If you do this, if you send me this kind of message, it will be a success. I'll do something. I'll transfer some money for you. If you send me this other kind of message, it's going to be an error. I'm going to respond back and tell you to clean up your act. So contract has a lot of different pieces. Generally speaking, if you're providing a contract as an API provider, you want to document that contract. You want to tell the developers who are going to be working with the contract, like, okay, what does a successful request look like? What does a successful response look like? There are a few standards for documenting contracts. The sort of biggest one by a good stretch is OpenAPI. There are a few others out there. Excuse me. What's interesting about pretty much all these standards is that they're machine readable. So an OpenAPI file can be YAML, can be JSON, but at the end of the day, it's machine readable, and that's pretty interesting because you can actually do some interesting second level things with API documentation. So you can actually turn around and implement functionality based on it. So within OpenAPI file, knowing absolutely nothing about how it's implemented or what have you, I can actually create a playground and say, okay, this isn't real data, but like developers can kind of start to play with it and get a feel for how it works, which is a really useful thing when you're actually writing code against it. You can actually auto-generate software to work with an API. I'll take a look at that in a minute. You can do contract testing. So there's kind of an interesting tool called Pact, which lets you say, like, I'm going to write tests against the contract that was provided in this OpenAPI doc. I'm going to validate that every change to the software meets the contract, right? So we don't wind up with errors in production. Validate that every change to the code meets the contract. And if it doesn't, your code actually can't go out. And so, you prevent errors in production. And I think what's really neat is that API docs can actually be auto-generated from stub code. So usually my workflow when I work with APIs, or sort of when I'm creating a new API, is I'll put together like a stub project. I like to work in .NET, but you can do this in a lot of others. I'll put together a stub project with one function for each API route that I want to implement. And I'll describe the objects that I want to take in and the objects that I'm going to spit back out, right? So just, they're called POCOs in C#, plain old C# objects. They just have, the properties that you're going to take in, properties that you're going to put out. And using a library like Swashbuckle, I can, inside of 5-10 minutes, I can create an OpenAPI file based on that. Then I can hand it off to my consumers and they can go play with the documentation. So that's pretty cool stuff. An example I like to point people to is Swagger Editor. Bit of historical trivia. The OpenAPI file OpenAPI format used to be called Swagger until mostly about 5 years ago. They renamed it. But you still see the name bumbling around. Swagger Editor, if you go there, it'll give you right out of the box like a sample API for managing a pet store. And you can actually go and play with the sandbox and fiddle with the the contracts and get a feel for how it all fits together. So I put together a little demo here to show you, kind of how you can play with it. I believe I actually have to exit full screen, click play, and then do this thing. All right, so we are taking a look at Swagger Editor. This is an online editor for API documentation in the Swagger format, also known as OpenAPI. So there's two parts of it here. On the left-hand side, you have the API documentation. These are various contracts that the API provides. And down here on the right, you see kind of a sandbox of that API. So for example, looks like I can find pets in the pet store by status. I can try out this API. I can find all the pets that are sold. And, scroll down here, you see a bunch of different dogs and cats, it looks like. I can go and get the same data in JSON format, so on. So what I'm going to do now, I'm going to show you just how easy it is to sort of add new bits and pieces to this API. So I'm going to add just a little hello world route. Oops, you can see it down here. So what this API is going to do, you call it, you say get/hello/shy or what have you, and it's going to come back with a string that says hello shy. Nothing very exciting. But here's what I think is pretty neat. Swagger Editor has tools for generating a server based on the contract. So I'm going to go ahead and choose Python Flask, which is just one of many frameworks for creating APIs. And you'll see that it generates a bunch of code for me. I'm going to open up the hello controller in VS Code. Okay, and as you can see, it's got a function that corresponds to my route, and it's got a variable that corresponds to the route parameter, the name variable. So I'm just going to say hello, whoever it is. Great, and so as you can see, in just a couple of minutes, I was able to go from just sort of declaring at a very high level what the contract for my API would be, down to working code that's actually going to turn around and do something useful. All right, thanks very much. Cool. So hopefully that gives you kind of a flavor of the kinds of things you can do with APIs and how you kind of get started working with them. There's lots of different kinds of tooling available. Swagger Editor happens to be pretty quick, kind of bootstrapping mechanism, but there's Java Spring Boot, there's .NET Core that will provide similar kinds of tooling, obviously specific to those languages. So I've been focusing a lot on REST, but there's lots of other kinds of things out there. REST is a pretty good general purpose API protocol, so it's pretty easy to do basic CRUD on objects, create, read, update, and delete. And it's pretty good for scenarios where reading an object and writing an object are more or less equivalently important in your API. It's a little bit clunky if your data model is really big and complex and there's a lot of relationships across it. It can certainly work out fine, but it gets a little cumbersome if you have like sort of a real dense web of connectivity between objects in your data model. Another flavor that's somewhat newer, it was created at Facebook. Again, I can't remember exactly when, but inside the last 5-10 years. It's optimized for reads, particularly scenarios where you're grabbing lots and lots of data from the server with lots of different pieces, lots of different properties, and it tends to feed rich UIs really well. which makes sense if you think about Facebook. The Facebook newsfeed has tons of different pieces of data on it. And so that's sort of what it's written for. GraphQL can do writes. It has this thing called mutations, but that is definitely not the emphasis. I won't even mention SOAP because it's such a painful protocol. I would not wish it on anyone. The other flavor is messaging, outbound messaging. So this is has been popular for a long time, but in the last, I'm gonna say again, like 6-7 years, when Apache Kafka was released, it's really sort of jumped. So the idea here is to kind of fire and forget event notifications. So again, assuming, let's say I'm the server and I get a payment request and I send out a payment response, like I can notify out like, hey, a payment was made, right? And then I put that on what's called the Kafka topic, and other people can go and listen to that topic. Other, I should say, systems can go and listen to that topic and do interesting things like, oh, Hermione Granger paid Harry Potter, like maybe we should, send an email about that. Maybe we should send a Facebook message about that. Maybe we should do something else even more interesting, like ship a product, that kind of thing. What it tends to result in is nicely loosely coupled systems. So in that case where you have the payments API firing off a message, somebody made a payment, and there's another system somewhere else that's sending an email as a result of that, the payments API doesn't need to know that the email was sent. In fact, it doesn't even need to know that the email system exists. And that can be a very nice property in cases where like you want independent teams to move separately. So you have your payments team kind of doing its payments thing. You have your email team doing its email thing. And neither really needs to work with the other very closely in terms of coordination if you have this kind of architecture. So it's very attractive for certain use cases. All right. We use Kafka super heavily at Wayfair, so it's always an interesting topic. But I'm going to turn a little bit.
Hey, Shai.
Yeah.
Do you mind going back into the slideshow, making it like full screen?
Oops. Thank you.
No problem. Just easier to see. Thank you.
Yeah, absolutely. Yeah. I got so carried away about Kafka. Like, oh my gosh. Okay. Let me turn a little bit toward API gateways. So this is a project I'm working on and have been working on for several months now. Probably will be for another year or two. Who knows? Here's kind of where API gateways are useful, and here's what they do. Okay, so let's go back to the pet store example, right? You have a server that provides like this pets resource, and you have a client, could be a browser or somebody else that says, hey, I want to get some pets. You send an API call, and you're done. Okay. But in some cases, you want some kind of authentication or security around your API. So if you think about that API call I showed you in the demo where like, oh, I'm just going to get the list of pets that were sold. It's actually kind of sensitive information, right? I might not want my competitor down the street to know how many pets I've sold in the last month or something, right? So we're going to add some security. And the way you generally do that is with what's called bearer token authentication. The client gets this thing called the token and embeds it in the header of an API call, sends it to the server. Server validates the token, usually with a separate thing called an authentication service, something like Auth0. And assuming the token is valid, you're off to the races. Problem here is that this arrow, this validation token process can actually be rather cumbersome to implement. It can be somewhat complicated. And so this is sort of the beginning of why gateways are useful, right? So the idea is, your browser sends an API call. Instead of directly to the server, it sends it to the gateway. And it's got the bearer token in it. The gateway validates the token with the authentication service. And then assuming that everything goes well here, it proxies the request to this API server. The API server goes and gets the pets, and kicks it upstream. So what you've done is you've offloaded the validation work to the gateway. The API server doesn't actually need to care about it or even think about it. So that's really attractive. Again, like you can have different teams. You can have your gateway team working on this validation logic. You can have your pet store team focusing just on the pet store data model, and you can kind of move independently and nimbly. So that's pretty neat. What's even neater is that you can go and reuse that logic, right? So let's say that, instead of just pets, I also want to sell, like books and TVs or electronics, right? So now I need 3 different services, one for pets, one for books, one for TVs, right? But I want to use authentication for all 3 of those services. Well, I just add more services behind the gateway. I've already implemented the authentication logic, so none of these services need to worry about authentication logic. So that's kind of neat. And what's even neater is that authentication is really just the beginning of the story. There's plenty more to do, right? So you can add caching logic. The gateway can say, for any given request that's coming in, the gateway can say, like, I've seen this request before. I know that the underlying data hasn't changed. I can just serve it out of a rapid cache. And the request never even makes it to the upstream server. And the client gets a response back really quickly. You can do logging, you can do rate limiting, you can do lots of interesting things at the gateway. So they're really powerful pieces of technology and relatively simple, models for how to deploy APIs. Of course, there's no such thing as a free lunch. Right? So there's all kinds of traps with gateways. Probably the biggest one is uptime. If your gateway goes down, you're really screwed. So what are we going to do about that? Your gateway can take a long time to process requests. And of course, the client, doesn't like that. So how do we speed up the gateway as much as possible? There's interesting problems around like maintainability and testability. So generally the client doesn't know or care who's implementing caching logic, for example, right? But they tend to blame the pet store team or the TV store team or whoever if there's a problem. So as the TV store team, as a pet store team, like how do I, ensure that these pieces of functionality work together? How do I test them locally before they go out to production? Things like that. These are all like important questions that we're tackling, pretty much live all the time. So this is the kind of stuff that, has been my focus for say about 5-6 months now. And I think it's going to be our focus for quite a bit longer in my team. So these are very like real in the trenches type things that we're doing. And of course, this is just the beginning. At Wayfair, we've been developing and serving APIs for, I'm going to say 7 or 8 years now, although I'm going to get the exact time wrong. And this is just the tip of the iceberg. We think there's lots and lots more interesting problems to go and lots of interesting opportunities that we can flesh out. So it's a pretty exciting time. If you have any interest in this kind of work, definitely encourage you to apply. Link to the career portal is right here. You're always welcome to give me a shout, connect on LinkedIn, what have you. Always happy to help. And aside from that, I'm happy to take any questions you might have. So thank you very much. And I'll check in the chat to see if there's any questions there.
Yeah, awesome. Thanks so much, Shai. That was super. Would love to hear from anyone if anyone has any questions. And then again, I will be online with some other representatives throughout the weekend. If you have any additional questions on this workshop or anything with Wayfair, would love to meet with you and get your interest. So any questions you have, feel free to drop them in the chat.